Today's lesson is on limits either at vertical asymptotes or as x approaches infinity. So let's take a look at the first example. I've kind of thrown in some graphs here. So let's take a look at this first example. It says limit as x approaches a equals positive infinity. So what that looks like is if you have a graph at an asymptote typically, where the graph goes towards infinity in the positive direction, then that's what that would say. So in this case, a from here's a, and then if we're approaching a from the negative side, that would be this line over here. And as you can see, this graph continues to rise. So technically, there is no limit here. The limit does not exist. But what we typically say is that that would be positive infinity, because the graph continues to go up and up and up. And we say that just so that we have an understanding of what the graph is doing as x approaches a from the negative side. And then the same thing happens for the second example. As x approaches a from the positive side, that would be this side over here. And that is also continuously growing, so that would also be x is approaching positive infinity from the positive side. And because these two things are the same, the limit as x approaches a would also be positive infinity. In the second graph, this would be what would be happening if x is approaching a going towards negative infinity. So from the negative side, you can see that the graph is going down and down and down. So that would be negative infinity. From the positive side, it is also going down, 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 which would be negative infinity. And then because, again, these two things are the same, the limit in general as x approaches a would be negative infinity. We have a third example where the limit as x approaches a from the negative side would be positive infinity. And the limit as it approaches from the positive side would be going down, which would be negative infinity. And because these two things are different, this limit does not exist. So this could be flip-flopped from the negative side. It could be going towards negative infinity, but as long as they're different, then the limit does not exist. So that's three examples of limits at asymptotes. The second type that we're going to look at is what happens when our x values continue to get larger, either towards positive infinity or smaller towards negative infinity. So let's take a look at this first example. We have the limit as x approaches positive infinity. That would be, what does the graph do as my x values get larger and larger and larger? So my x value is going this direction, larger and larger and larger. What does the graph do? The graph gets closer and closer and closer to this horizontal asymptote, which in this case is the value L. So again, it never touches L because it's a horizontal asymptote, but those values get closer and closer and closer. Same thing in this case when x gets closer and closer to negative infinity. So when my graph, when my x values get smaller in the negative direction, what does the graph do? The graph also gets closer and closer and closer to this horizontal asymptote value, which is L. And again, you may have more than one horizontal asymptote. You might have two. So the values going towards positive infinity and negative infinity may be different. The other type that you might see is in this case where they don't get closer to a horizontal asymptote. They continue either positive or negative towards infinity. So in this example right here, where the limit x goes towards positive infinity. So again, what is happening when my x values get larger and larger? Well, my graph gets smaller and smaller and smaller and continues to go towards negative infinity. So that would be what that limit is. In the other example, when x is going towards negative infinity, so when my x values get smaller and smaller, what does my graph do? Well, in this case, my graph is increasing, so towards positive infinity, so that's what my limit would be. So those are the two different types of limits at infinity. Either does the graph continue towards infinity up here in this first examples, or does the graph, do we want to know what the graph looks like as our x values get larger and larger or smaller and smaller? All right, so let's take a look at this example here. We've got this graph with a whole bunch of asymptotes, and then also we want to look at the end behaviors. So this first example, limit as x approaches -9 from the negative side. -9 is right here, and from the negative side, those values are getting larger and larger, so that would be positive infinity. Same spot, -9 from the positive side. So in this case, from the positive side would be this side, getting smaller and smaller, so negative infinity. And -9 in general, because these two things are different, that limit does not exist. Okay, now we are at 3, which is right here. So 3 from the negative side. 3 from the negative side goes towards positive infinity. 3 from the negative side, I'm sorry, I did these backwards. The first one, 3 from the negative side, oh, I'm sorry, I did that right. 3 from the negative side is positive infinity. 3 from the positive side is also positive infinity. And then because those two things are the same, the limit as x approaches 3 is positive infinity. And finally, we are at 7. So 7 is right there. 7 from the negative side would be negative infinity. 7 from the positive side would also be positive infinity. I'm sorry, negative infinity. And then because both of those are the same, the limit as x approaches 7 would be negative infinity. Finally, what happens to the graph as we get larger and larger or smaller and smaller? So in this case right here, x approaches negative infinity. That would be my x values getting smaller and smaller and smaller. Well, what does the graph do? The graph goes towards negative infinity. And then in this example here, x goes towards positive infinity. So my x values are getting larger and larger. My graph is also getting larger and larger towards positive infinity. So that would be my answer for positive infinity. Okay, take a second, pause the video, and work on example 2. Okay, so I'm assuming you've done example 2 at this point, and here are the answers for those. Look through those. If you have any questions, either shoot me a message through Schoology or check in at the appropriate class time and ask any questions there. Either way, you have a homework assignment to do that's based on these notes. So again, if you have any questions on that, please let me know.